Is day 25. It's Tuesday, February 25th. And we just started Unit 3 yesterday. Now, I was not here for that. And based off of the exit tickets I just looked through, it seems like you guys did a really nice job grasping this, even without me here. But I know that sometimes it does not kind of soak up into our brains when we're not getting the same type of instruction we're used to. So we will do some review of this today. Make sure we're all feeling good about it and on the same page. But yesterday, what you guys should have been learning about is factoring. So whenever we are doing these 4 problems I gave you, I have a couple of different expressions written below, and we are supposed to factor each of these expressions. Who can tell me what does that mean? What are we going to be doing with each of these problems exactly?
Finding how many times each can go into the other at an equal, and we take the highest number that's on the same perimeter of each side.
Yes. Yes. That is wonderful. We are trying to find if there is a number that fits into both of the terms we have in our expression. We're trying to see what the greatest common factor is. So, in case you didn't talk about that yesterday, I'm going to give you an acronym. Basically, that is letters that mean something. So, GCF. We will talk about these 3 letters a lot. So, I would write them down. This means greatest common factor.
We watched that video on that one.
Good. So greatest common factor, that just means the biggest number that can be multiplied to get the same, these 2 terms here. We want to make sure that we find the number that fits into both of them. That is the largest. So let's think about number 1. We have 15x plus 5. What would we want to think about to start solving number 1? How would we factor this?
Write down how many times, like we know 15 times 1.
Yes.
And then
so we can start
find out
listing
how many,
factors.
Yeah.
So 15, maybe over to the side I could write factors of 15. And then I like to make a little T chart like this.
T. Okay.
So you said 1 and 15. What else?
And 5.
We could do 5 and 3.
Yeah.
The next one up we could do is, yeah, I really think that's it. 1 and 15, 3 and 5.
That's it. Yeah.
That's it.
Yeah.
We could do 5 and 3, but that's the same numbers. Okay. And what are the factors of 5?
Just 1 and 5.
Just 1 and 5. So now we're comparing. I'm trying to see what is the biggest number that is in both of these, 15 and 5.
5.
Yes. I could see, well, 15 is the biggest number here,
It's
but
the biggest,
that's not under 5
Yeah.
also. So it won't be 15, won't be 3. There's no 3 over here. Now all we have left is 1 and 5, and 5 is bigger. So
we put that up underneath the 15 and the 5.
yes, that means we're going to divide both of these terms by 5. So what is 15x divided by 5?
3.
3x. Good. And we'll bring down our plus sign. How about that? And 5 divided by 5?
1.
1.
Those in parentheses.
Uh-huh.
Then put the 5 on the outside.
Yes. That is the most important part. Do not forget to bring your greatest common factor. Don't forget to write the GCF outside of your parentheses. So now, how could we check that this is correct? Do we know how to check our answer? Did we go over that yesterday? Okay, I'm going to show you how to check your answer because this is what made factoring make sense to me. Factoring is reverse distribution. You guys remember distributing whenever I would take 5 times 3x, 5 times 1? If I distribute the answer I came up with, I should come up with 15x plus 5. And if I do, my answer is right. So let's double check. What is 5 times 3x?
15.
15x. Plus, what is 5 times 1?
5.
5. Look at that. It worked. We're just doing distribution in reverse.
And that was on the video. I'm sorry.
Okay,
That
good,
We did
good.
see that on the video.
That's okay. It's always a good idea to, revisit those different things we're doing. So this is our answer though. 5 times 3x plus 1. That's the answer. That would be our fully factored version. Do we have any questions on number 1? You guys want to look at number 2?
Yes, please.
Scooch it over. Okay, so how are we going to start number 2?
By the GCF.
Yeah, let's find our GCF. Okay, so let's see. I have 10x squared and I have 2. What are the factors of 10?
1 times 10
1 times 10
and 2 times 5.
and 2 times 5. Okay, let's see. What are the factors of 2?
1 times 2.
1 times 2. And that's really it. So let's see. Let's compare our list of numbers here. I don't have a 10 with my 2, do I?
No.
So let's cross that off. I know 10 is not going to be the greatest common factor. There's only a 5 under my 10. There's no 5 on the 2, so I'm going to cross my 5 off. That can't be the greatest common factor. Now I have 1 and 2, and I have 1 and 2. Which is my bigger number?
2.
2. So what's our greatest common factor? Our GCF. 2. Good. So I'm going to take that 2, and I'm going to go ahead and write it over here where my answer is going to be, and then start a parentheses. So since my GCF is 2, what am I doing with that 2 to find what goes in the parentheses?
Divide.
Divide. I'm going to divide by 2 for both of these. So 10x squared divided by 2. What would that give me?
5x.
Yes, 5x squared. Good. Now, why does the x squared not change to x, or doesn't get rid of the x?
There ain't no x on the other side.
Yeah, there's no x's that we are dividing by, so that just stays the same. We don't change it. Good. Now I have minus 2 divided by 2. What's 2 divided by 2? 1. So 5x squared minus 1. There it is. That would be our answer. But let's check it. Let's make sure. Okay. Oh. So let's double check our answer, and let's do that by distributing. So what is 2 times 5x squared?
10x squared.
Good, it's 10x squared. What is 2 times 1? 2, good. And 10x squared minus 2, that's what we started with. So this is our answer. We did it right. Awesome. Okay, and as we are doing any of these problems, if at any point you don't know why I wrote something I say or put on the paper doesn't make sense, stop me, let me know that, and we can absolutely address it. All right. We're just going over the do now problems, so they're posted up here. I didn't print off a paper, but you'll be able to see them as we do them together. Okay. Do we have any questions about number 2? Any questions at all? Okay, let's look at number 3 then. Number 3, I have 3x plus 6. Do we have a greatest common factor here?
3.
Yes. I can do 3 divided by 3. I can do 6 divided by 3. If we wanted to double check, we could make a list of all our factors again. 3, I just have 1 and 3. 6, I have 1 and 6, and then 2 and 3. And if I were to mark off all the numbers that they don't have in common and just look at what we do have in common, our biggest number that they both have would be 3. So 3 is our greatest common factor. So we're dividing by 3. So what is 3x divided by 3?
1x.
1x. Good. So I'm just going to write x. 6 divided by 3? 2. So it would be 3 times x plus 2. And that would be our factored form. That is our answer. Let's double check it. When I distribute 3 times x plus 2, what happens? 3 times
3x.
Plus 3 times 2, 6. And 3x plus 6 is what we started with. So this is the correct answer. Any questions on number 3? Let's look at number 4 then. So number 4, this one's a little bit trickier because not only do we have numbers that are going to be a common factor, but we also have x's. Both terms have at least x. This one has x squared. What is that going to mean for us whenever we're finding our greatest common factor?
They're gonna have an x.
There's going to be an x in our GCF because whenever we're trying to figure out the numbers that multiply to get to each term, we can take an x out of both of these, can't we? There's x squared here, there's x here. Drop my pen, Cat. Okay, so let's focus on the numbers first and then we'll look at the x's. So we have 12 and 4. So what are my factors of 12?
1 times 12.
1 times 12.
2 times 6.
2 times 6.
3 times 4.
3 times 4. Good. Factors of 4.
1 times 4.
1 times 4.
2 times 2.
2 times 2. And that's it. So, what is the biggest number that is shared as a factor of both 12 and 4?
4.
4. 4 is the biggest number over here on 4. And even though we go up to 12 and we have 6, that's not under both lists. We have 4 for both. So,
4 is going to equal 12x squared.
yes, we can divide by
4x.
4 for both of these. Now, let's see. What happens when I do 12 divided by 4?
Well, should we go back and put all, like she taught us yesterday, put the x's down?
Let's do the x's too then. Yeah,
And then
absolutely.
Put 2 x's down for the 12 and 1 x down.
Yes. Since there's an x in both of them, we're going to bring down an x to cancel the x's. Now, why are we only doing 1x? Why can't I do 4x squared on both?
Because there's only one. You got to take a x from because of the 2
Yes.
Well, she told us yesterday, put the X's down
Uh-huh.
and then go and take one away and then whatever's left. we
Yes.
do. Yeah.
Yes, exactly. So on our first term, 12x squared, we do have x squared, which is x times x. We've got two x's there basically. And then 4x, there's only one x. I cannot take away more than one x from 4x because there's only one to begin with. So let's see. What happens to 12x squared divided by 4x?
3x.
We get 3x. Got my minus. And 4x divided by 4x is
1.
1. Good. Now, what goes outside here?
4.
4x. My GCF goes outside. That 4x is the GCF, the greatest common factor. Okay. It's a little trickier. Having the x in makes it a little tougher. Now let's check our answer just for good measure. What's 4x times 3x?
12x.
12x
Squared.
squared, good, minus 4x times 1 is 4x. So that's the same as what we started with, 12x squared minus 4x. So that means we factored properly. That's good. That is our answer. Awesome. Okay. So this was our do now. I will put these up for just a moment in case anyone wants to kind of peek and look at that. And today I want to do a quick review of exponent multiplication and making sure that we know what is happening exactly when we have x squared, maybe x to the third power, to the fourth, to the fifth, just so that we are doing things correctly as far as factoring goes whenever we get higher exponents on our variables. So I see a few people writing still. I'm going to pause this for a moment, give you guys a second to copy down anything that you don't have yet. I'll pause this. Okay, so that is our do now. And before we do any more factoring, I'm going to go ahead and start a page of notes, and we're going to get some rules written down. Just make sure we understand everything. So I'm going to title my page. Number 1.
8 weeks. But we didn't have.
So for our notes today, we are going to talk about exponent multiplication. So I'm going to give myself a little title here. Exponent multiplication. So here is what we're going to talk about with exponent multiplication. Whenever we have exponents, that's that little number at the top right corner above a number or above a variable, such as x squared. So when we have x squared, what this means is x times x. Remember, we have a base. The base is what's being multiplied. So x is our base in this example. And the number, the exponent up here, tells us how many times we multiply the base. So if I have x to the 6th power, how many times would I be multiplying x?
Yes.
6 times. It would be x times x times x times x times x times x. That's all that this means. Whenever I am multiplying however many x's, that number of times I multiply becomes my exponent. So what would happen if I did x times squared?
X times X and then, so do a square first, and then you'll times it by whatever you get.
Okay, so what would my new exponent be?
Drop the exponent?
The exponent, what do you mean by that?
Well, like, let it go down, because you can't do X1. I don't know, never mind.
Okay, so here, let's talk about this. We know that x squared means x times x, right? So why don't we just kind of rewrite this? What this really means is x times, and I'm going to rewrite x squared, it's x times x, right? X times x. Okay, now from what we see in above, the 2 lines above here, however many times I multiply x by itself, that is the number that I get for my exponent. X times x, I did it twice, my exponent is 2. X times x times x times x times x times x, it's 6 times, my exponent is 6. Now I have x times x squared, which is the same thing as x times x times x. How many times did I multiply x? How many x's are here?
3.
3. So my exponent is going to be 3. All we have to do is think about our x right here is really like x to the 1st power. So that's just x. I'm not multiplying anything until it says I'm multiplying by x to the 2nd power, which is x times x. So this comes out to be x times x times x. 3 x's, so it's x to the 3rd power. Thank you. So all that happens when we multiply exponents is essentially, the shortcut to this is we can add the numbers together that are in our exponents. So let me zoom in a little. X times x squared is x to the 3rd power. We can also think of this as x to the 1 plus 2, which gives us x to the 3rd, 3. So let's try something different, but we're gonna remove the parentheses, just to show that it's all kind of the same. The parentheses might be confusing us a little. What if I gave you x? Let's see. squared times x to the third power.
X to the fifth power.
X to the fifth power. How'd you know it was going to be x to the fifth power? Just add 2 plus 3. X to the second power times x to the third power is just like x times to the 2 plus 3 power, which gives us x to the fifth. We could also think of it like this. X squared is just x times x. So 2 x's times 3 more x's. And you could count. There's 1, 2, 3, 4, 5 times that x is being multiplied by itself. So x to the fifth power would be our answer. How about x to the fourth power times x to the 10th power? X to the 14th power. How'd you know, Lisa? 4 plus 10. Good. X to the 4th, x to the 10th. We just add the 4 plus 10, and that gives us x to the 14th power. Good. So keeping these rules in mind, I wonder if that will help make factoring make a little more sense, especially when we have something like this. This helps us understand why whenever I have x squared and I divide by x, we're getting rid of one of the x's, which turns it into 1 of x. There is no more 2 because we took away 1. So let's see. What if I add some numbers in? What if I did 4x squared times x? Do 1 x.
4x to the third power.
Ooh, okay. So you are correct, Barbara. Say that one more time, though, Lisa. What were you thinking? You said 1x. Are you talking about the second term here? Okay, yes. So we could think of this as 1x. And similarly to when we don't have a number in front of a variable, whenever we don't have a number for an exponent, we can also assume that it's 1, right? So here's some 1s. So we would just start by thinking about multiplying the numbers. We don't even need to worry about the x's yet. What's 4 times 1?
4.
4. What is now x squared times x to the first power?
2.
2, and then 1. What did we do in the other problems when we multiply the numbers? We add them. What did you say?
3.
3. So we'll get 3. So we will get 4x to the third power. We wanted to write out our work. Here's really what's happening. We have the 4 times 1. And 2. And that gives us 4x to the third. Okay, so I'm kind of just trying to show you the reverse of factoring so that we can understand when there's bigger numbers, how x's come out of things, how numbers come out of things, how we can kind of make a distinction there. Let me grab. I'm going to pause this for just a minute. So here is what my plan for you is today. Looking back at my notes, I would like to give us some more practice problems so that we can all do some on our own and I can kind of see each of your individual comfort levels with this stuff. And then I want to be able to offer some one-on-one help as we go through these. So, what I would like for us to do while I get some of those things ready is I'm going to go ahead and give you your guys your break a little early today. That way you're not just sitting here while I'm looking for my worksheets. So I'm gonna pause this video and we'll take a little break. So we're back from our break. And here's what we were just talking about. Our exponent multiplication. I see a few more people joined us from one more attendance. Okay. Okay. So this was just kind of a little review of the multiplication rules when we have exponents on our variables. And I'm going to tear this out and start a new page. And we're going to do some practice. So I'm going to give you some practice problems. And in these practice problems, it's going to be the same thing we did yesterday, same thing we just did for the do now. I'm going to give you some expressions with two terms, and I'm going to have you try and factor out the GCF, the greatest common factor. And then I'm going to throw in a few that have more than two terms, just to see if we can do that. So, factor. Before I give you a whole bunch of them, I want to run through these with you just to make sure. We haven't done anywhere we have bigger exponents on both of our terms. So let's just make sure we all understand what we're doing here. Look at number one together. So, remember when we are factoring our greatest common factor, I want to think about what numbers can I multiply to get each of these terms. So, I'm going to do it like this. What numbers can I multiply together to get 4?
1 times 4.
1 times 4. What else?
2 times 2.
2 times 2. That'd be a little difficult to see. Can you guys see the green is a little light? Okay. And then how about 8?
1 times 8.
1 times 8.
2 times 4.
2 times 4. Okay. So, thinking about our numbers first, what is the biggest number that goes into both 4 and 8?
4.
4. Good. So, I know that I can divide both of these by 4. So, I'm going to write a 4 out to the side. Now, how am I going to know what else is part of my GCF in terms of x?
I would put down 3 x's for the 4.
Okay, so would you write x, x, x?
Yeah. And
Okay.
then for the 8, I would put 2 x's.
Good, so x,
And I
x.
would take 2 x's from each side, which leave 1 x.
Okay, so there's 2 x's over here and there's 2 x's over here. So since there's at least 2 x's in both of the terms, what do I write next to my 4?
4x squared.
4x squared. Yes. Yes, yes, yes. Now, before we move on, does everybody understand where the 4 came from, where the x squared came from? Okay, so let's talk about, let's see, make a line and kind of see if I can simplify this as much as possible. What I'm looking to see is what can I divide both of these terms by? 4x3 and 8x2.
Divide by 2.
You can divide them both by 2, absolutely. Let's see. How do I want to write this? I'm trying to think of the best way to lay this out to give you guys a good visual of what's happening. Let me try this. So we can divide them both by 2. Let's start with doing that. What happens when I have 4x to the 3rd power and I divide it by 2? Does my x change? My x won't change because I'm not dividing by an x. So I'm still going to have x to the 3rd power. Now, what's 4 divided by 2? 2. So I've reduced this down to 2x to the 3rd power. Now let's see, 8x squared divided by 2. What's 8 divided by 2? 4. And then I still have x squared, right? We haven't done anything with the x yet. So we divided by 2. Can I divide 2 and 4 by anything? I can still divide by 2 again. And I get 2 divided by 2 is what? 1. Good. So I have 1 x to the 3rd power. Or you could just write x to the 3rd power. We don't need the 1 necessarily. What is 4 divided by 2? 2x to the 2nd power. Okay. So what I'm going to do is I'm going to write the steps in a different color. Okay. Now let's see. Can I divide by any more numbers? No, I can't. I could divide by 1, but that wouldn't change either of these numbers. They're going to stay the same. So we've reduced the number value as far as we can go. But now let's look at our x's. I know that x to the 3rd power means x times x times x. So I'm going to write that. 2x to the 2nd power just means 2x times x. So there's 2 x's here. There's 3 x's here. Right? Okay. So what is the biggest number of x's that fits into both of these? 2. I only have 2 x's right here. So I can't do a different number that's bigger. I need to do the biggest number that fits into both of them. In this case, it's 2 x's that fit into both. So x times x is x squared. So if I were then to divide by x squared, here's what happens. 2x squared divided by x squared. These will cancel out. And we just get 2. That's all that would be left there. And then up here, let's see, x cubed divided by x squared. We're getting rid of the x's. How many x's is left up here? 1. So this is a way longer and more complex way of doing this. But let's see. This is where we're coming up with the 4x squared. We divided by 2 and divided by 2 twice. So if I divide by 2 twice, really dividing by 4. That's 2 times 2 is 4. And then we divided by x squared. That's the third thing. We got x squared, 4x squared. Okay, then we need to see what's going on up here. If I take 4x squared out of 4x to the third power, what am I left with? Let's see.
2.
So what can cancel? My 4's cancel. Now if I have 3 x's and I take 2 x's away, how many x's will I have left? 1. So this cancels and we end up with x. We have 8x squared also being divided by 4x squared.
X plus 2.
X plus 2? Yes, that is right. 8x squared over 4. Yep, 8 over 4 gives us 2. My x squareds cancel. That's where we get our second term from. This would be our factored answer for number 1, 4x squared times x plus 2. Okay. Just pause for a moment. Right, I know. Okay, so again, this is a way to do it, but it's like the very long, complicated, doesn't make a lot of sense way. I'm going to rewrite number 1 and let's simplify this process. Now, Jenny, can I call you out and have you help me with this one? Because I feel like whenever you are giving answers to each step of the process,
Am I doing it
you
wrong?
seem, no, you're doing it really well. You're doing it correctly. I want to know what exactly are you doing to find your factor? Because even just writing out the x's, I thought that was such a smart idea because that helps us visualize.
That's what she did yesterday, and it helped me too.
Okay.
So I had to take some away.
Yes. So tell me, like, what are you writing when you're trying to factor? What are you writing under?
Let me write it out first.
Okay. All right. We're reworking number 1.
Okay, so when I look at the 4, Where, okay, on them, where I don't know them third power.
That's okay.
Hey, I'm gonna use this chart that she gave me yesterday,
Okay,
and that's gonna help me.
so
So I'm
if
gonna go to the 4.
you're wondering, let me pull out that chart, and ask everyone, does anyone need this paper? Okay, 1, 2, 3. So this paper is a big list of factor pairs. Basically, like if our number is 4, I'm gonna look at my paper. To get 4, I can do 1 times 4 and 2 times 2. This is just a little helper guide. So 3 of you need it. Does everybody else have one? You need one? Okay, perfect. I have 4 copies. If anyone else needs them, I'll have to make some more. So who are the 3 that had their hand up? 1, 2. Oh, I need 4. Okay. How about this? I'll give the 4 out for now. But at the end of class, if one of you would let me see your paper so that I can make copies of it in case anyone needs it in the future, I would appreciate that. Oh, you're welcome. Okay, so Jenny, go ahead and tell me now, what did you
So
do?
I'm gonna take my fingers, because I know I got the 4 and the 8, so I'm gonna go to the 4 and the 8 on the paper.
Okay,
Then I'm gonna look at all the numbers.
okay, so she went to the 4 and the 8 on the factoring paper, and under the 4, we have what?
Well, we have 1 times 4 and 2 times 2.
1 times 4 and 2 times 2.
On the 8, we have 1 times 8, 2 times 4.
Awesome, 1 times 8 and 2 times 4. So these are the factors of both of our numbers.
So then I'm gonna look and see, I know I got the 1 and the 4, gonna be the 2 and the 4, because that's a 4. But
Mm-hmm.
the 8 and the 2, I don't have to worry about them. 8's too high, but it's not an even one. I know the 4,
Yes.
4. So I'm gonna put the 4 up underneath the 4 in
Yeah,
a line,
like that.
and then square, yeah, and then an X squared, whatever. 4 on that side too.
Okay, perfect.
And then now me, so I can get it right.
Uh-huh.
Since it's both the X's, I'm gonna go down a little bit. I'm gonna put 3 X's.
Now, do you write that like under your 4
No, I go
or
down
above
further.
your?
No, I'm just gonna put some X's.
Okay, I'm gonna write
To
it
the
above
side,
the
yeah.
terms, if
Yeah.
that's okay. So
Yeah.
I know
It just has
X to the 3rd power means I have 1, 2,
2,
3
right.
X's.
and then the 8 to the
X
X
to the
power.
second, we've got 2 X's. Good.
Now Jenny's gonna take 2 of them X's away from each side.
Okay, so that's smart. So basically you're kind of, oops, let me make that not blurry. So you're seeing how many X's do these terms have in common? So it's like there's 1 X they both have. There's 2 X's they both have. So since we crossed off 2 X's, what do we write with our 4 under here?
4 to the X. 1.
So 4 X.
1. Yes.
Now, how many X's did we cross off?
4. 2 on each side.
2 each side. So we'll put a 2 right there.
There we go.
Okay, okay. So this is our greatest common factor. We found it. We found it. All we did is we saw on our factor list, what are the factors of 4? What are the factors of 8? Then we thought, what is the biggest number that is under both of these lists? Well, they both have 1, but that's not the biggest number, so I'm going to cross it off. They both have 2, but there's a number bigger than 2. 8's too big because 4 doesn't have 8. Oh, they both have 4, so that's where the 4 came from. And then the X's, how many can we cross off on both? 2 each. So we have 4X to the 2nd power. Okay. Does everybody see where we at least got the 4X squared from?
Yes.
Yes, yes, good. Okay, so now we've found our GCF, our greatest common factor. It's 4X squared. How do we get to the second part where we need to find our answer?
So we put the 4X outside of a parentheses.
Yes, we're going to have our greatest common factor on the outside,
Make a parenthesis.
and then we'll have something in parentheses. Okay, so how do I know what goes in parentheses?
Oh, you're gonna divide there's one x left, so that's gonna be your 4's will cancel out,
Mm-hmm.
so that leaves you with x.
Good. So I'm doing 4x to the third power divided by 4x to the second power. 4 divided by 4 is 1. So the 4's are canceling. I have 1 x over 3 divided by x2. That gives us 1x left here. Since the 4's cancel and we have 1x left, what's the term I'd be writing right here? Just x. Okay. And I'll bring down my plus.
4 divided by 8.
My x squareds will cancel. And then 8 divided by 4 is 2. There we go. Perfect. Perfect. And if it helps you to see how many x's we're going to have in each of our terms, here's another way to write it out. I'm going to write these below here. Instead of 4x to the third power, we could just write 4x plus 8x squared is 8x. And then when we find our greatest common factor, which is the 4x squared, 4x, 4x. Now let's look at what cancels. So if you have the same thing on top of a fraction as you do on the bottom, you can cross them off. 4 on top, 4 on bottom, cross them out. X on top, X on bottom, cross them out. X on top, X on bottom, cross them out. You're only left with an X. That's where that first X comes from. Then for our 8x squared over 4x squared, I can see that my x's will cancel out because I have 2 x's on top and 2 x's on bottom. And now I'm just doing 8 divided by 4, which is
2.
2. So it's really going to turn into 2 over 1, which is 2. So that's where we're getting the x plus 2 on the inside. Okay. Does this make more sense seeing them written out as XXX?
Yes.
I think it makes more sense to me too. Yeah. Good. Good. Do we have any other questions about number 1? I think I'm starting to figure out the format that's more helpful. Makes a little more sense. Does anyone still need this? Can I move it? I do see some people still writing. I don't want to move this if you're copying down notes. Okay, I'm going to move this then, and we're going to look at that number 2 together.
Nice. Did I fall down?
I mean, that sounds like somebody slammed up against the door or something. Oh, it's crazy. Like, I really can't concentrate.
It's hard. It's like really hard.
I need to like play some white noise. Oh, it's so crazy.
I can hardly hear you.
I bet. Ugh,
They're taking all of my good eating.
I know. Well, let's see. Okay, so I'm just making another page of notes for that number 2. Page 3. This is our day 25. Okay, so here's that problem number 2. We have 12x to the 4th power minus 6x. So I want to find the greatest common factor, the GCF, of this expression of these two terms here. So what should I look at first? 12 and 6. Okay, so if you've got that little cheat sheet with your factors listed, somebody tell me, what are some of the factors of 12?
1 times 12.
1 times 12, 2 times, go ahead.
6, 2 times 6, and 3 times.
Good. 2 times 4.
6 is 1 times 6, and 2 times 3.
Okay, so I've got all of my factors listed out. And let's do this. I'm going to kind of number my steps. Step 1 is we're finding the factors of the numbers. That's what we're doing first. So 12 and 6. Now, of all of the numbers we have listed under 12 and 6, what is the biggest number they have in common?
6.
Ooh, okay, so I heard 2, I heard 6. Let's see. 2 they do have in common, but we have numbers bigger than 2 as well. We've also got 3, and we've also got 6. So sometimes it's good to start by crossing them off in order. I like to start from the biggest number. So if you understand how to recognize this really quickly, that's great, but I'm going to explain it really quickly just in case. The first thing I would do is look for the biggest number listed. The very biggest number listed is 12. Now I ask myself, do both of these, 12 and 6, have 12 listed underneath?
No.
No. So I'm going to cross off 12 since it's not under both. Now I'm going to look at the next biggest number. Under 12 I have 6. Do I have a 6 under 6 as well?
Yeah.
I do. You want to pick the biggest number. So GCF is biggest number in common. So we're finding the number factors first. And our greatest common factor is 6. So we'll go ahead and write 6 under both of our terms. So the first step is done. We've looked at our number factors. Now let's look at our x's. How many x's do I have in my first term?
4.
4. So I'm going to write here, factors of x's. So 12x to the 4th power has x, 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 x. 4 x's. And how many x's are here in 6x?
1.
1. Okay. So what is the biggest number of x's that I can put into both terms?
1.
1. There's only 1 right here. So that's going to be the biggest number that we can do. So let's see. Only 1. So that means I'm going to take this x, and where should I be writing x?
Next to 6.
Next to my 6. So we've looked at our numbers, we've looked at our variables. Now we have our greatest common factor. It's 6x. That's the biggest we can take out of it. So now let's write our factored form. I found my GCF. Where does that go in my answer?
Outside the perimeter.
Outside of parentheses. So I'm going to write 6x. And now I want to divide, my goodness, I want to divide 12x to the 4th power by 6x and 6x by 6x.
2x to the 3rd power minus 1.
Yes. 12 divided by 6 is 2. X to the 4 divided by x to the 1. 4 minus 1 is 3. Bring down my minus. 6x over 6x is 1. Oops, I missed my x.
I was gonna say.
That was a no. I can't. You cannot forget your x's, guys. That's something you'll get points taken off for, and I just did. My bad. I'm gonna blame it on the hallway noise. Okay, so again, if we wanted to, we could think of it like this. I'm taking 12x, x, divided by 6x minus 6x divided by 6x. Just another way to write it out. If we wanted to, we could cross off the x's in common. You'll see we have 3 x's left. That's where the 3 came from in our answer. My 6 and my x cancel to 1. And then 12 divided by 6 is 2. Okay. Is it starting to come together in our brains a little? Okay.
I have a question.
Yes.
Whenever you put the 1 by that x underneath the 6,
Right here?
the 6x, your factor.
Right here?
Factor, yeah.
Yes.
Because I was watching a video and it was telling me to subtract from the top to the bottom.
Yes.
So that's kind of like confused me because the video, I'm doing it the way the video taught me, but when I go and do the question, it's not adding up. So I know you subtracted the 4 from is it the x?
Like 4 minus 1 makes 3?
Okay.
Yes.
Because I was going to put the 3 on the outside for some reason.
Okay. So that might just be a confusion between what goes where because this is new to us. Let me give you like a little key. And honestly, I think this would make sense to go over this as well. We talked about exponent multiplication. Let's make sure we understand the division too. So I'm gonna make a quick little note under here. Exponent division. So whenever I have, for example, like looking back to multiplication, I'll pull back that page. Whenever I had x to the second power times x to the third power, we just add the 2 plus 3, and it gives us x to the fifth power. Multiplication and division are opposites. So if we add when we multiply, we're going to subtract when we divide. If I were to give you x to the sixth power divided by x to the second power, this would be the same thing as x to the 6 minus 2. And our answer would be what? X to the fourth power. And it's the same thing right here. X to the fourth power minus x to the first power is x to the third. 4 minus 1 is 3. Now, if thinking of it as subtraction is blowing your mind up a little bit and it feels uncomfortable, don't forget you can also do it this way. Let me get a different color out. X to the sixth power is the same thing as 1, 2, 3, 4, 5, 6. So I'm gonna write this out. Okay, so I drew 6 x's. And then how many x's would I need on the bottom? 2. So we could just cancel out the x's since we're dividing and see how many x's are left. We should get 4 on top. So I have 1 x on top, 1 x on bottom. Cross them out. 1 x on top, 1 x on bottom. Cross them out. So these cancel. And how many is left? 1, 2, 3, 4. There are 4 x's left. You'll get the same answer. So I'll give you another one. How about x to the 10th power over x to the 4th power? X to the 6th power. How'd you know? What'd you do?
10 take away 4.
10 take away 4. It's the same as x to the 10 minus 4. Or x to the 6th. We could also draw out 10 x's on top, 4 x's on bottom. When we cross them off, you'll see what's happening. 1, 2, 3, 4, 5, 6, 7, 9. 1, 2, 3, 4. The reason we can write it as subtraction is because what's happening is for every x on the bottom, we take away an x on top. Since there's one x here, I'm taking away one on top. Since there's another x here, I'm taking away another x on top. Since there's another x, we take away another, and we take away one more. So how many x's did we subtract?
4.
4. So we started with 10 on top. We took away 4. 10 minus 4 is 6. And look at this. 1, 2, 3, 4, 5, 6. There are 6 x's. The picture will work just as well. Sometimes it's a great way to, just double check. It takes a little longer to write the x's out, but if it lets you feel a little better about it, you feel more sure when you do it that way, then absolutely, I encourage you to do it that way.
So quick question.
Yes.
Exponent, division, we subtract the exponents, and for multiplication, we add them.
Yes.
Okay.
Yes. And if you want a little key for that, I'm going to make a sticky note that you can move your pages on, and I'm going to write exponent rules. So if you would like to have a sticky note to write these little rules on as well, there should be some at your tables in those rectangle bins. I like to write these little rules on sticky notes because then I can move it with me to the next page. So on here, we're going to write the multiplication rules and the division rules. But when you're multiplying, add, and then I'll give an example for each, such as x to the 6th times x equals to the 6 plus 3. And what would our answer be here? X to the 9th. Good. And I'll draw a little picture under there. 2, 6, 2, 3. I could say count all the x's. Same thing. So there is the multiplying rule. We just add the numbers. And we're going to look at the dividing. And that is subtract. So, for example, x to the 6 over x to the 3 How would we solve that?
Subtract.
Subtract. What are we subtracting?
63.
6 and 3. So we have x to the 6 minus 3, which is what?
3.
X to the third power. Good. You just subtract when you divide. And I wish that sticky note was a little bigger. I'm going to add a second one to it. Take it together. Draw a little picture for that. So it would be just like this. 1, 2, 3, 4, 5, 6. There's my x to the 6th. Over 3, x to the 3rd. And for my picture and multiplying, all I did was count the x's. In dividing, we're going to be canceling the x's. So cross off x's that are on top and bottom. We can cancel 1, 2, 3 of them. And we're left with 3. Which gives us x to the 3rd power. These are the two major exponent rules that we will be using whenever it comes to factoring. There's my exponent rules. Okay. Does anybody need a little more explanation on the exponent multiplication and division? Do we feel okay about it? Okay, sure. Let me give you some practice on this specifically. I think we jumped into factoring really quick, and you guys are getting it awesome, but it is super important to make sure we understand these are kind of the fundamental things that we didn't really go over much. Can I move this, or does anybody need it right now? Anybody still writing? I'm gonna move it, but I'm gonna still kind of keep it on my paper. Let's see. I'm not gonna start a new problem yet. I'm gonna give you a few that I do want you to try on your own. What if I have just do these 3 and let me see what happens. And if you finish this, I'll give you one more to see how you feel. Your one. See if we can do number 4. That'll be kind of the challenge problem. And I'm gonna give you a little over 5 minutes. I want you to try those on your own, and we'll look at them together. All right, let's look at these. See how we did. What'd you guys get for number 1?
X squared.
X to the what?
10 squared.
To the 10th?
Yeah.
Everybody else get that? x to the 10th power. How'd you get that? Adding 3 plus 5 is 8, plus 2 is 10. Good job, guys. Good job. How about number 2? X to the 10 again. How'd we get that?
Fraction.
Subtraction.
12 minus 2.
Yes. 12 minus 2 is 10. Very good. Now, number 3 was a little tricky.
5x to the 7th power.
Ooh, 5x to the 7th power. Did anyone get something different?
I did 5 times x to the 7th.
Okay, 5 times x to the 7th. Well, guess what? That's exactly what this says too. So that's correct.
So
Perfect.
x to the 7 times 5 is correct.
Yes.
Okay, that's right.
Now, if in the future, what we want is for our numbers, I want to say that we call them coefficient, but our whole numbers, we want those to come before the variable. Just for in the future, it'll make simplifying things a little bit easier, but 5 times x to the 7th power is the same thing as x to the 7th power times 5. So those are both correct. Now, did anyone get x to the 12th power? You got that to start?
Mm-hmm.
Okay, so tell me why. Do you know why that wouldn't be correct?
Because the 5 supposed to come before the x, right?
Yeah, so this is just a 5. This is not x to the 5th power. This is just 5 by itself. So the only numbers that we're adding are the exponents, 4 and 3. 4 plus 3 is 7. And when we take x to the 7th power times 5, I don't know what x is, so I can't really do anything other than say 5 times x to the 7th power. It'd be 5x to the 7th power. That's our answer.
Miss Taylor,
Yes.
that word coefficient, is that the word?
Yes.
It was in that video yesterday.
Was it?
Coefficient is a number?
Yes.
Okay.
Yes.
Other than variables and all that other
Yes.
stuff?
So there's a few different words in math. Let me pull up the actual definition because that might be more helpful. Coefficient. Okay, so a coefficient, if you are curious, is a number that is multiplying a variable in an expression.
Okay.
So a coefficient, there's no coefficient here unless we wanted to say that 1 is, because there's an invisible 1. The coefficient here is 5.
Okay.
And if you're curious, that's COEFFIGINT. Now, this is not something I'm going to be quizzing you over. I don't need to know that you know what a coefficient is, but
because they used it in that video.
Yes.
So
I won't be quizzing you over that. But it is a word that as we get into higher level math, especially if any of you are planning on going into college math courses at some point, you're going to hear this word and your teacher might just assume that you know what it means. Coefficient is just a fancy word for a number in front of a variable.
Okay.
That's all
Thank
it
you.
is.
Thank you.
Yeah, absolutely. And thank you for asking that because I bet you were not the only one wondering. Number and so that's number 3. How about number 4? What'd you guys get for that?
4x to the 4th power.
Ooh,
4x
4x.
to 4.
4x to the 4th power. I heard 4x to the 10.
7x to the 4th power.
4x to the 10. 7x to the 4th. Any other answers? I want to hear all of them. Even if you think it's wrong, confidently tell me. Did anyone get something different than these 3 options?
I know it.
Everybody got one of these 3? Okay, so let's talk about it. Who got 4x to the 10th power? Okay.
I already know that is wrong.
Ooh, could you share with us what you did?
Added the 7 and the 3.
Ooh, so you added the 7 and the 3 and you caught it. What were you supposed to do? subtract. So remember when we have a division problem, x to the 7th divided by x to the 3rd, we are crossing out and canceling the x's to see what's left over. We're subtracting. So I'm going to write out a picture too. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3. So let's see. I can cross out 1, 2x, 3x, and I'm left with how many? 4. So I know that this is probably going to be one of my answers. 4x to the 4th power or 7x to the 4th power. Polly says she recognized what happened there. It's not going to be to the 10th. Now, see, how am I going to figure out what my coefficient is?
Divide.
We're dividing. That's all we're doing. What's 28 divided by 7? 4. So 4x to the 4th power is our answer. It wouldn't be 7. Now, did anyone get 7x to the 4th and is confused about why it's not 7?
Don't mind me, but I did get that, but don't mind me. I know when I get
Okay, so you got it now. Good. So it won't be the 7. We're just dividing. 28 divided by 7 is 4. Okay. Are we feeling okay about all this?
Yeah.
I think you guys seem to be picking up on it much better now. We probably should have started here rather than jumping straight to factoring things with 2 terms. So in the future, I'm going to make note of that. But you guys have done really, really well, even though we kind of did this in backwards order. But
I'm a 9.
number 9.
No, I'm a 9.
You're a 9 out. I love that. That makes my day. Good. Okay, so now that we've kind of reviewed this, let's go back to the factoring itself. I am going to pull out a new page unless, does anyone need this? Okay. I'm going to start a new page of notes. This will hopefully be the last page before I get you an exit ticket. And I'm going to work on getting you guys lots of practice if anyone is interested in that. Some practice worksheets. So Algebra 1, again, Unit 3. Still day 25 notes. Four. After each expression. See. I'm going to give you something a little trickier too. What if I gave you 36x to the 6th power plus 12x to the 4th power plus So now I'm giving you something with 3 terms. Giving you something with 3 terms. So, what should I do first?
How do we add them all up together?
Add them all up together?
The big numbers first.
You mean add my exponents together? What do you mean add together?
36, 12, and 18.
Okay, so why am I adding these three numbers together? Can we add them together?
Find the factors.
Yes, yes. So these are not like terms because their exponents are different. We actually can't add these, but we can find the factors of them. So why don't we find the factors of, let's make a list for each. Factors of 36, factors of 12, and factors of 18. So 36, and let's start from like smallest to biggest. And you are correct, Alana, it is going to be 6. So 36, I can do what numbers?
36.
1 and 36, 2 and what?
2 and 18.
18, 3 and
3
what?
and 12.
12, 4,
9.
4 and 9,
6 and 6.
6 and 6. Okay, so that's all of them for 36. How about 12? 1 and 12, 2 and 6, 3 and 4, and that's it. 18, we have 1 and 18, 2 and 9,
3 and 6.
3 and 6. Is that it?
Yep.
Okay. So let's start with our biggest numbers. I know 36 is my biggest number, but that is too big. It's bigger than 12 and 18, so I know it's not going to be a factor of those. So let's just get rid of 36. My smallest number here is 12, right? So I know my greatest common factor cannot be any bigger than 12. So any of the numbers bigger than 12, we know we're not going to use. I'm not going to use 18 because 18 doesn't go into 12. I'm not going to use, well, let's look at the next biggest number. 12 goes into 36. 12 goes into 12. Does 12 also go into 18? No, so it's not 12. How about 9? 9 goes into 36. 9 goes into 18. Does it go into 12? No. So this time we have to make sure it goes into all three. So it's not 9. The next biggest number is 6. Does 6 go into all three numbers? It does. 6 goes into 12. 6 goes into 18. And 6 goes into 36. So, what does this tell us?
Our greatest common factor is at least 6.
Yes, our greatest common factor, and I appreciate that you said is at least 6, because it's not just 6. We also got to look at the x's. But since we know that 6 is the biggest number that is a factor of all three terms, we're going to start by writing 6 under all three terms. So we have found the greatest common coefficient factor. Let's look at our x's. So, how are we going to figure out how many x's I can take out of each of these?
You write them all out.
We could write them all out. Let's do that. So, for 36, x to the 6th power, I have 6 x's. So, well, I'm going to write them up here, actually. 1, 2, 3, 4, 5, 6. There's 6 there. 12x to the 4th power, we've got 4 there. 1, 2, 3, 4. 18x to the 3rd power, we've got 3 there. 1, 2, 3. So, how do I know how many x's I should use?
Sure. Each X can go into the same number.
Yeah, I know exactly what you mean. We need to make sure that however many x's I'm writing down here with my 6, that it's a number that is big enough that it gets rid of as many of these x's as possible, but small enough that we're not taking away too many. So if I wrote x to the 6th power under all of these, that wouldn't work. That would be too big. I cannot fit 6 x's into 4 x's or into 3 x's.
3.
So out of 6, 4, and 3, my biggest number of x's that I can fit into all 3 of them is 3. Is 3. Good. We could think of it like that. I've got 3 x's here. That's my smallest number. I can fit 3 x's into all 3 of these. It works. Okay, so what am I writing next to 6 for all of these?
3.
x3, x to the 3rd power. Good. So 6x to the 3rd power is our GCF. That's what we just found, our GCF. Found it. What do we do next?
Write it out.
We're going to write it out. So I'm going to put my GCF over to the side, outside of parentheses in my answer. Get another. I've got 6x to the 3rd power, and then I'll have some parentheses. And how many terms am I going to have inside my parentheses? 3. I started with 1, 2, 3 terms. My final answer is going to have 3 terms. Okay, so let's start one at a time. We've got 3 division problems. 36x to the 6th power over 6x to the 3rd power. So really I have 36 x, 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 6 x, x, x. Goes in here. What is 36 divided by 6? 6. And I know I'm going to have an x, right? X to the 6th over x to the 3. What's that going to give me?
3.
X to the 3. Good. I can cancel out 1, 2, 3 x's, and then I've got 3 left over. So 6x to the 3rd power. So we've done our first term. Now let's look at our second term. 12 x to the 4th over 6x to the 3rd. What happens here? What's 12 divided by 6?
2.
2. So did that, and how many x's?
1, 1.
2. I can cancel 3, and I'm left with 1. Now, if I have 2x to the 1st power, do I need to write that 1? You don't. This is a little extra rule to keep in mind. Exponents. Just a quick side note. X to the 1st power is the same thing as x. Anything to the 1st power is itself, because x to the 2nd power is x, right? So the 1 is telling us how many times we've got an x. 1. If I had 5 to the 1st power, it's the same thing as 5. 5 to the 2nd power would be 5 times 5.
So, quick question.
Yes.
Once you find that greatest common factor, that's when you can go through and start subtracting your.
Yes. That's when we start dividing.
Okay.
Yes. And I think what would be super helpful for us tomorrow, I'm going to try and have like a little step-by-step guide that we make together with kind of written instructions for guiding through this, because even as I'm looking at this, I'm imagining myself as a student way back when, and I'm thinking like, this would make a lot of sense to me in class, but I know if I went back later and tried to do it on my own, I think I would forget where to start. So I want to try to prevent that for you guys, and we'll make a little guide together tomorrow probably. But that is correct. That is correct. Okay, so I did my second term. 12x to the fourth power over 6x to the third power. We got 2x. 12 over 6 is 2. 4 minus 3 is 1. Okay, last term. We have 18x to the third. 18x over 6x to the third. What's 18 divided by 6? 3. And what happens with my x's? They cancel. 3 minus 3 is 0. Here's another fun rule. Anything to the 0 power, no matter what, is 1. It could be 5 to the 0. It's 1. Doesn't make a lot of sense. We could go into more depth about why that is tomorrow as well, but I'm going to end up taking all your time away. All we know is that if we have x to the third over x to the third, it ends up canceling, and we get 3 times 1, which is 3. So we don't really need to worry about it being 1. We just need to worry about the fact that the x's cancel out. Okay, it will not change our answer. Now we have our final answer. That was a long one. 6x to the third power times 6x to the third power plus 2x plus 3. There it is. That's the factored form. That's it. Okay. Now I'm going to give you going to focus more on these factoring things tomorrow. For your exit ticket, I actually want to focus more on the exponent multiplying and dividing rules, just to make sure that I can see your work, see how well we're doing on that. So I'm going to give you an exit ticket. I will make a copy, so you're welcome to wait for it, but you do not have to, because I know we only have about 5 minutes left. I'm going to make that in front of you real quick. This is our day 25 exit ticket. So your instructions on this exit ticket are going to be to simplify each expression. When I say simplify each expression, that just means if it is written as a division problem, it'll be problems kind of like these. It means get it to the simplest answer where it's all combined. So you're just solving the problem. This is just a fancy way of saying it. So for number 1, got these 4 problems. This is due on Friday. If you have any questions about it, feel free to ask. I'm gonna run and make a copy of this real quick though, so let me freeze my screen. And I will be right back. Pause. Okay. Oops. I know lunch starts in about 30 minutes. If any of you are working on this and it's going into lunchtime, that's fine. I don't want to rush you out if you're right in the middle of finishing your problem. But that is going to be it for today. I'll make copies and I'll be right back.